Alright, here's our question. This is a circular motion question. If you're curious, this is from question 31 in your textbook on page 241. Okay, I'm just going to look through this question and highlight some important parts. A 400 kilogram roller coaster passes upside down at the top of a loop-de-loop, having a radius of 30 meters. The centripetal force at the top is a result of two sources. Well, let's get rid of that. Result of normal force and gravity. Okay, well, I'll just put result of two forces here. So it's normal force and gravity, and it says determine the magnitude. So this is asking you what to do. Determine the magnitude of the force if the centripetal force is 5,000 newtons at the top. So it's telling you the centripetal force right here. Let's do this in nice blue here. Okay, so before we start anything else, we just looked at the question, tried to understand what the question is asking us. There's different parts that I highlighted. You can circle, underline, whatever you want to do. And now I want to, once I've read the question, I want to draw it. Or sometimes even as I'm reading the question, as I'm seeing, oh, this is a roller coaster on top of a loop-de-loop, I might start drawing even then. But let's start here. And draw ourselves a loop-de-loop. Okay, so here's our loop-de-loop, and at the top here we have a mass of 400 kilograms. Fantastic. And we are told it's at the top of the loop-de-loop. Got that. Radius of 30 meters. Let's see if this becomes useful. We'll see. 30 meters, but I just like to understand the situation. We'll just write everything down. Radius of 30 meters. The result of, so the centripetal force at the top is the result of the two forces. So we may as well just write that down actually as well. And so FC equals, says the result of those two forces. So it doesn't really tell us much, but it says something like FG and something like FN. They're somehow related. The result of the two forces. I'm going to tell you it's adding, but we're going to think about that for a little bit based off of what else we know about circular motion questions and what we've learned previously. Okay? So then it asks, determine the magnitude of the force. Okay, so we're looking for Fn. And it tells us the force centripetal. Okay? So this is just sort of a relationship. We don't know what that is for sure yet, but we'll leave it as what I just wrote down. But let's look at the situation in terms of Fnet. So Fnet equals ma, right? But what is Fnet in this case? Well, if it's at the top of the roller coaster, Fnet is Fc. Fc is F1 plus F2 plus F3, or Fnet is 1 plus F2 plus F3, okay? Fc is just equal to Fnet, okay? Alright, now looking at this, we have Fc equals, what's force 1? Well, force gravity. If we draw a free body diagram here, let's do that. Let's go ahead and draw a free body. Here's a force of gravity. And perpendicular and away from the surface is the normal force. So actually we have a second force adding on to that. Well, let's use blue. Second force adding on to that, Fn. Okay, so if they're both down, they both add tip to tail. So again, there's the tail of the red one at the top right by the mass, and then there's the tip, and then it's added to the tail of the blue one. Okay, so Fc equals Fg plus plus Fn. We know Fc, it's given to us over here. Let's just circle that again. Fc is 5,000. Fg, well, actually we don't know it yet. Let's write that out more simply. Fc equals, what's Fg? Mg plus our little Fn. Okay, now let's just move this down a little bit here. Let's try to move the mg over to the other side. Well, we subtract mg here. So the two mg's on this side cancel with each other, and we have Fc minus mg equals Fn. Okay? Now Fn equals, Fc was what? 5,000 newtons minus, what was the mass? 400 kilograms. Right over here. And what was gravity? Well, that one's constant, 9.81 meters per second squared. Just a fun anecdotal thing. We're doing this on Earth. Maybe you can think about what it would be like on the moon with roughly a quarter of the gravity. So just think about it. What would that change in terms of centripetal force? Kind of interesting. Anyways, so here we can just add those things together, and we have Fn equals, and this is what your textbook writes, but I don't like this answer as much, 1.1 kilonewtons. What I would write instead, what I like better, is 1.1 times 10 to the 3 newtons. Okay? I like this scientific notation better. It is easier to read, and it's just nicer. Okay? And you don't have to keep converting between kilo whatever or mega whatever or micro whatever. If you leave it in scientific notation, it's just the better form. Okay? So there's your answer for this question.